Hey guys, this is Mr. Simmons for ICP and the Behavior of Gases. In this section, Behavior of Gases, we want to conceptualize how gases exert pressure on its container. And we also want to explain how a gas is affected when pressure, temperature, or volume are changed. So our vocab in this section is pressure. So what is pressure? Well, the forces that exist in fluids, such as a liquid or a gas, are caused by collisions of the particles in the air. Those collisions create a force over a certain area, and that's what pressure is. Pressure equals force divided by area. So inside this balloon, we have molecules flying around. They're colliding with each other and the sides of the container, and that is a force over a certain area, so that is pressure. So the units for pressure, force is in newtons, area is in meters squared, and pressure is in newtons per meter squared. So the atmosphere has pressure. So please follow this line of reasoning. So air has weight. So air has matter that's flying around in the form of gas, and that gas is matter. So it does have mass, and we have a pull of gravity on that mass, so it does have weight. So all around us, we have a pressurized gas system. The weight has a force. The force exerted on our bodies, on everything else around it. And so if we have force exerted over an area, we're going to have pressure. So at sea level, there's 101,300 newtons per square meter. So there's a lot of force all around us. Supposedly in a square meter, there is the force, the weight of a truck bearing down of pressure in that square meter. So on the outside of our body, we have this pressure all over us. But the thing is, we have pressure in the inside too, so it equalizes. So we have basically equal and opposite forces, so we do not experience the force. When you change your sea level, like when you go up on top of a mountain, on a roller coaster, or in an airplane, you're increasing your altitude, so that decreases pressure, and your ears start to pop because your body's trying to equalize with the pressure around it. If you were to dive deep into ocean, then you'd have a lot more pressure on you because you're going deeper in the way of the water above, so you can feel that pressure on you. So here's a couple examples of pressure. Here's the gasket of a tire. So here we're going to check tire pressure. There's a simple little tool to measure the pressure of a tire. We have pressure in our basketballs, footballs, soccer balls, the reason why they can bounce around. We also have pressure in our tires. So when we're thinking about gases, we have to think about volume, temperature, and pressure. Those are three variables that really affect it. And so Boyle's law is part of a bigger law called the combined gas law. But Boyle's law deals with pressure and volume. So as the pressure of a gas increases, the volume of that gas decreases. And likewise, as the pressure of a gas decreases, the volume of that gas increases. So this shows how pressure and volume are related. Pressure and volume are inversely proportionate. So if one goes up, the other one goes down. And so pressure and volume are inversely proportionate to each other. So this is an apparatus called a bell jar. Basically, it's a big vacuum. You can suck out the air. So right here, if air is being sucked out right here, so air is going to be leaving, hold out right here, there's less pressure over here. So since pressure goes down, what's going to happen to volume? Well, the volume of the gas increases because pressure and volume of the gas are inversely proportional. There's less pressure pushing it together, so this gas is going to increase. And if we start introducing pressure back into the system, pressure is going back in, we're going to have more pressure in the bell jar, and so that's going to push these gas molecules closer together, so volume is going to decrease. So pressure and volume are opposites of each other. Guy-Lussac's law deals with temperature and pressure. So as the temperature of a gas increases, the pressure of that gas increases. So they are directly proportional. They go in the same direction. So likewise, as the temperature of a gas decreases, the pressure of that gas decreases. So you may have seen, like on the outside of an aerosol can of spray paint or whatever sprays out, it says keep away from heat. The problem is this can is pressurized. There's pressure in there, and if you heat it up, that pressure increases will eventually bust the can. So because the volume of the gas wants to increase, the pressure of the gas wants to decrease because the molecules are moving faster. So if you have faster moving molecules, you're going to have more force, and that means more pressure. If the pressure goes down, if you decrease the temperature, the pressure goes down, you can actually get a can to crunch. Charles' law has to do with temperature and volume. And so Charles was actually a famous scientist in France, I believe, a long time ago, and he invented the first hot air balloon for the king to get advantage over a battlefield. And so they wanted to float a balloon up so they could actually see what's going on in the battlefield and be able to use flags to give signals around. So he discovered as the temperature of a gas increases, the volume of that gas increases. And likewise, as the temperature of a gas decreases, the volume of that gas decreases. So going back to the air balloon, if you increase the temperature of the gas inside, it'll want to expand. The volume will expand because the pressure is expanded. And so as it expands, as the pressure expands and the volume expands, it becomes less dense than the air around it, and it will rise. Likewise, if you cool off a gas, it will, so temperature is going down, the volume will go down. So temperature and volume go in the same directions. They are directly proportionate. So some real life applications of the gas laws. We have our hot air balloon. So here we're heating up air. The temperature goes up, so the volume wants to go up, so it spreads out. Tires, if we increase the volume, if we were to increase the volume of these tires but still have the same amount of gas inside, the pressure would go down. Likewise, if we decrease the volume of these tires, pressure will go up as there's less room to go around. But it's important for this pressure to be there so these tires can work properly. All right, guys, and that's it. That is the behavior of gases. We wanted to conceptualize how gas exert pressure on a container, and that's because gas molecules are moving all over the place. They're in constant collision with each other in the sides of the container. That's over a certain area, so we have force divided by area. That is pressure. And we explained how gas is affected when pressure, temperature, and volume are changed. So Boyle's law was pressure and volume. They are inversely proportionate. If you decrease one, the other one will increase. If you increase one, the other one will decrease. And then pressure and temperature, Gay-Lussac's law. If you increase the temperature of a gas, pressure will go up. If you decrease the temperature of a gas, pressure will go down. And then Charles' law, if we change temperature, volume is going to change in the same way. If we increase the temperature of a gas, the volume of the gas will go up, and vice versa. If we decrease the temperature of a gas, the volume will go down. Thank you and have a great day.